Hi, everyone. Welcome to your notes on pedigrees. Pedigree is a chart that's kind of like a family tree, and it's a way of showing inheritance through generations. And you can do it to show lineage and passing on of traits throughout a family. So this would be a pedigree showing a color blindness in a family. Females are circles and males are squares, or in this case, rectangles. And so you'll see that this one up here is a female that is a carrier. It is half orange, half yellow. So when you're half and half, you are a carrier, meaning that this woman is not colorblind, but she can pass it on to her children. So this male that's yellow has normal vision. And these are two sons. They had two sons, both of which are colorblind, which means they got this X, the colorblind, from their mother. And then this colorblind son married a female with normal vision, and they had a daughter who was a carrier for colorblindness and a son with normal healthy vision. That's how you would read that pedigree. Let's go on and learn a little bit more about them. It says, why are more males than females colorblind? And when we did our X-linked notes, we learned that things that are carried on the X chromosome are more likely to males are more likely to show them because they cannot be a carrier. They either have it or they don't. So if you have that recessive trait on your X, since you only have one X, it shows. So a pedigree is like a family tree. It shows genetic connections amongst individuals. It has standard symbols, and it can be used to estimate probability and patterns of inheritance over generations. Some of the basic symbols of a pedigree chart are squares for males, and if they are affected by it, it's filled in dark. If they are unaffected by whatever the trait is, then it is blank. Unaffected for females is a circle that's blank, and affected for females is a circle that's filled in. We're not going to have any diamonds, which are people whose sex is not known. But if you go back far enough in a family lineage, they just may not have enough information about a specific individual to know what their sex is. A line between symbols here shows marriage or mating. They had kids together. And this vertical line coming down from a marriage line is showing offspring. So this would be a mother and a father that had a son. And if you have more brothers and sisters, then you just make another horizontal line off the vertical line and attach all the kids coming down from that. And if they come down here in off at the same point, then they're twins. We won't have any examples of twins in our pedigrees. Here's a few extras. If they're a carrier, it can either be half and half, or it can be a circle in the middle. And you'll see it both ways. We're not going to have any sex unspecified or proband. We're also not going to have any deceased, divorce, or consanguineous. You do need to know about a couple and how to represent their offspring and whether they're affected, a carrier or unaffected. We aren't going to have any examples of adoption, but if you adopted a baby, then this is how you would show it with the dotted lines around it. If you gave a baby up for adoption, then you would count it this way, so with the brackets around it. And then these are examples of twins. So monozygotic are going to be your identical twins, meaning one zygote or one fertilized egg split into two babies. So they have the same genetic information. Dizygotic means two zygotes. So you have two eggs and two sperm. Those are your fraternal twins. And zygosity unknown means you don't know if they're identical or fraternal or not. So hemophilia is the royal disease. It's an X-linked recessive disorder characterized by the inability of to properly form blood clots. And it spread through the royal family of Europe through the descendants of Queen Victoria. And we discussed it a little bit in the last notes. And they ended up calling it the Curse of the Coburgs. This is a bigger version of the pedigree of Queen Victoria's. So you have Queen Victoria right up here. And she married Albert and had 1, 2, 3, 4, 5, 6, 7, 8, 9 children. One of her sons, Leopold, had hemophilia, and 2 of her daughters, Alice and Beatrice, were carriers for it. Then of her grandchildren, this is this next row down, she had 4 daughters that were carriers, or 4 granddaughters that were carriers, and 3 grandsons who had it. You'll notice most of the boys that have hemophilia never get married or have children. And that is because they probably did not live long enough to do so. Chances are that they died before they were ever able to have children. And then you can just see as it was passed from generation to generation, each new generation seemed to have more. And the pattern of inheritance is that you have females that are carriers for it and males that have it. Everybody that has it is a male. There are a couple modes of transmission. Autosomal dominant. Autosomal refers to chromosomes 1 through 22. So if it's on an autosome, if it's on any of those other chromosomes, 1 through 22, then it's autosomal. If it is dominant, that means that the trait is dominant and you only need one abnormal gene to get it. So there are no carriers with autosomal dominant. You either have it or you don't for both male and female. And you only need to get it from one parent in order to have it. You will see this type of disease showing up in every generation. And then autosomal recessive, it's a recessive disorder, meaning you need 2 copies of the gene in order to get it, and both copies must be present in order for the disease or trait to develop. Now, these are on your autosomes as well, so men can be carriers. And you'll see this as something that typically can skip generations. So you'll have it show up, and then you'll just have some carriers, and then you'll have it show up again a few generations later. And for sex-linked recessive, the pattern of inheritance here is that diseases are passed through families through the X chromosome, and it's sex-linked. So females can be carriers and males have it. And females can have it too, but they would have to inherit it from a father that had it and their mother who was at least a carrier in order to have the trait. So if you were to see this pedigree, what would you guess that the mode of transmission was? So you have a male that has it, a female carrier, and another male that has it. So this would be sex-linked recessive because you have female carriers and males that are affected. So anytime you see a pattern of males having it and females being carriers, you want to think for a sex-linked recessive trait. This example here where you have of the people that are affected, it's males and females, and everybody has it. I don't see any carriers. That is going to be autosomal dominant. So it's in every generation and no carriers. So it says Debbie married David and had 3 children, Darren, Dawn, and Derek. David, Darren, and Derek discovered they have muscular dystrophy. Derek married Dee Dee and had 2 children, Denise and Destiny. Denise also has muscular dystrophy and married Dirk. They had 2 children, Dee and Devin. Dee has muscular dystrophy. So here's the pedigree. Let's label who everybody is. So Debbie married David. These are the first ones. Darren, Dawn, and Derek. So Dawn has to be the girl. But then we don't know about Darren and Derek. So I'm going to put Dawn right here. Discovered they have muscular dystrophy. Derek married Dee Dee. So if Derek married Dee Dee, then this one would have to be Derek. Has a disease. Then we're going to shade them in. And so I am going to make them blue. All right. So we have David, Darren, and Derek discovering they have muscular dystrophy. So David, let me make it thicker here. All right, David is all filled in. Darren. Sorry, guys. My coloring with this a little crazy. Just imagine that I made it solid. All right, that's what you can do. You can imagine it. I'll clear it off and we'll make it solid in just a second. I just wanted you to show how I picked this. So they had 2 children. And they are Denise and Destiny. And Denise also has muscular dystrophy and married Dirk. So Denise must be this girl because she has muscular dystrophy and she married Dirk. So here we have Destiny and Denise. 2 kids, Dee and Devin. And D has muscular dystrophy. What I'm going to do here is actually erase my beautiful coloring. All right. And go to the next slide because it has it all filled in. So the same ones that I had marked solid are marked solid right here. And then if we try to put the genotype, first, everybody that has it, this is going to be an autosomal dominant because you have it in every single generation. It's passed pretty evenly through males and females. And so David, the father, is heterozygous for it. We know that because they have children that do not have the trait. So he has to have a healthy allele to give. In this case, the healthy alleles are the lowercase ones. So mom doesn't have it at all. So she has to be homozygous recessive. And dad is heterozygous. Dawn is homozygous recessive because she doesn't have it. You know for sure that everybody that doesn't have this is homozygous recessive. What you're looking for is whether the people that are affected with it are heterozygous or if they're homozygous dominant for it. So Darren has to be heterozygous because got one healthy allele from mom and then had to have gotten the diseased allele from dad. Otherwise, he wouldn't have muscular dystrophy. Again, that's the same thing with Derek. But because Derek married a woman that didn't have the disease, their daughter, Denise, has to have one of those healthy alleles also. So she has to be heterozygous for it. Again, she married somebody that does not have muscular dystrophy. So all of the people affected with it have to be heterozygous. And everybody that doesn't have it have to be homozygous recessive. And that's kind of the pattern you will see every time with autosomal dominant. All right. Thank you.